If I asked you to multiply that, what is it? Oh my. Really? No one? No one can multiply a times a plus 5? Yeah, look at each other. Come on, guys. I know it's Monday. We take the a and do what? Multiply it by everything inside the parentheses. What's a times a? So a squared plus 2 times 5. There. That's it. Did a lot of those last year. But we haven't seen one like this, where we multiply a 2-term polynomial by a 2-term polynomial, or a binomial by a binomial. Any idea how you might multiply it? Like if this was just x times x plus 2, you do x times x, x times 2, right? What do you think you do with this one? Same thing, times this, times this. So you do 4 multiplications. You take the x and distribute it through the terms in the second binomial, and then you take the minus 4 and distribute it through. So whenever you have a binomial times a binomial, it's 4 multiplications. What's x times x? X squared. X times 2. That's 2x. Minus 4 times x. Negative 4x. Minus 4 times 2. Negative 8. Can I do anything further with this? I can combine these two, yes. So 2x minus 4x gives me negative 2x. So my final answer is x squared minus 2x minus 8. Try the second one. See if you can do the second one. So 4 multiplications. Take the first term in the first binomial, multiply it by everything in the second. So you will get b squared minus 3b. Take the negative 8 and multiply it by every term in the second binomial. And you will get minus 8b plus 24. We can collect the 2 terms in the middle. So we get a final simplified answer of b squared minus 11b plus 24. Okay. So that's something new to you, is multiplying 2 binomials. Just remember when you have a binomial times a binomial, it's always going to be 4 multiplications. What if I asked you to work backwards? What if I gave you the answer and asked you what times what gives me this? Well, that is called factoring. Remember, factoring is breaking something up into something times something else. Okay. Well, it turns out we can see a pattern. But before that, I want you just to work on a little bit of mental math. You can do it on your own, you can do it with somebody else. I want you to answer the following questions. 2 numbers that have a product, multiply, to get 15, and have a sum, add, to get 8. What 2 numbers fit that? 5 and 3. How are the rest of them? Just to make sure you're on the right track, what would be the next one? Sorry? Negative 6, negative 3. Because those multiply to get positive 18 and they add to get negative 3. Sum of 2, product of negative 8.
-2 plus 4.
-2 plus 4. And of course, you could write 4 and then comma -2. Product of -10, sum of -3.
-5 and 2.
5 and 2. Sum of -7, product of +12. -4, -3. Sum of -5, product of -14. -7, +2. Product of -30, sum of 1. Two numbers that multiply to get 30. What comes to mind? 5 and 6. And one of them has to be negative. And we need a sum of 1, so it would be 6 and -5. A sum of 0 and a product of -16. Negative, that's 64. That gives you a sum of 0. You're on the right track. Two numbers that multiply to get -16.
4.
4. +4 and -4. Product of 40, sum of 14. 4 and 10. Sum of -6, product of -7. Well, there's only one pair of numbers that multiply to get 7. 7 and 1. And one of them has to be negative. But to get a sum of -6, you have to do -7 and +1. Okay. So there's a reason that I asked you to do this. Because we use this when we factor. Okay. When we get an expression that looks like this, a trinomial, where the first term is x squared, or it could be the letter a or j or whatever. The second term is minus plus something x. And the last term is a number, a constant, plus or minus something. When we factor it, when we break it up and what we multiply, it's always going to look like this. We just have to figure out what the numbers are. Okay? And there's a pattern to this. Let's multiply these two. So I have to do 4 multiplications. X times x is x times 4, 4x. And now multiply the 3 through the second binomial, plus 3x, plus 12. Simplify the two terms in the middle. And you get that as the final answer, right? Do you notice anything between the numbers and the binomial we multiplied and the number in the middle? They add. Those two numbers are a sum of 7. Notice anything about these two numbers in the binomials and the number at the end? They have a product. So how do we go from here to here? Well, first of all, we know it's going to look like this. And to figure out the numbers, we just need to find two numbers that add, have a sum of the middle number in the trinomial, 7, and have a product of the last number in the trinomial, 12. So it'd be plus 4 plus 3, or plus 3 plus 4, same thing. That's how we factor these things. So before we go on to the next page, let me give you another one. So now I'm going to ask you to factor this, break it up into two binomials. Always going to look, you don't have to do any math, Nick. It's always going to look like that. It's just the numbers in the binomials we have to figure out. And what are those two numbers? Well, they're going to have a sum of 3. And they're going to have a product of -10. What two numbers fit that? No, not an X. No, just tell me two numbers that add to 3. -2 and +5. Right? -2 plus 5 is 3. -2 times 5 is -10. So those are the numbers that go in. -2 plus 5. That's it. Boom. Mind blown. Rid of that. And how do you check? Multiply it through. See if you get back to this. If I multiplied it through, x times x is x squared. X times 5 is 5x. -2 times x is -2x. And -2 times 5 is -10. Collect the 2 in the middle. And you get that, which matches what we factored in the first place. So it works. So when you see a trinomial that's in this form, it's got an x squared at the beginning, then it's got something x, then it's got a number, it's always going to look like this. You just need to figure out the numbers. So let's just do a few examples. Let's walk through the first one together. Again, I'm not even going to do any math. I know my answer is going to look like this. I just need to figure out what are the numbers that go with the x's. And those two numbers will have a sum of 5 and a product of 4. What two numbers add to 5 and multiply to 4? Don't overthink. There's only one pair of numbers that multiply to 4. Sorry, two pairs. 2 times 2 or 4 times 1. Which one of those pairs add to 5? 4 and 1. Done. Figure out the numbers. Remember, add, so have a sum of -2, have a product of -8, -4, +2. If you wrote +2 and then -4, that's correct as well. Why does it keep going? Try the next two. And for D, Notice there's not a number in front of this, but what number is actually there? 1. So keep that in mind. Okay, so this one instead of x, we're just going to put a's. And I am looking for two numbers that add to get negative 12, multiply to get positive 35. Don't pick the two numbers that add to don't think what are two numbers that add to negative 12. Think first, give me a pair that multiply to 35. And then start playing around with adding them to get negative 12. So when I look at 35, to me, I think 7 and 5. But because this is negative, both the 7 and the 5 have to be negative. So negative 7, negative 5. Again, if you put negative 5 and negative 7, that's right too. This one here, we're back to x. So notice I set this up right away. Now I'm thinking two numbers that add to 1, multiply to get negative 20. So again, I'm going to start thinking of a pair that multiply to 20. And one of them is going to have to be negative to get negative 20. So 2 and 10. Now, if I make one of those negative and add them, I'm not going to get 1. Okay? 20 and 1, no. If I add those, I'm not going to, if I make one of them negative, I'm not going to get 1. 5 and 4, yes. But to make it positive 1, that means the 4 needs to be negative. So it should be plus 5 minus 4. 4 minus 4 plus 5 is also. And finally, just a little word problem here. We're told that the area of a rectangle, we're not given it as a number, we're given it as an expression, x squared plus 18x plus 80. And we're told that, or sorry, we're asked to find the length and the width. Well, how do we find the area of any rectangle? Base times height, or length times width? Either one. Well, I'm told the area, it's x squared plus 18x plus 80. And I need to figure out what times what gives me x squared plus 18x plus 80. Well, that's factoring. So we've got to factor this. So it's like the previous questions we've done. X and x. I'm looking for two numbers that have a sum of positive 80 and a sum of positive 18 and a product of 80. So I'm thinking of pairs that get me 8 and 10. So that means that I could call this the length and this the width. I could have done it the other way. X plus 10 is the length and x plus 8 is the width. But that's the same rectangle. It's just turned on its side. So I haven't finished the question yet. If this is the length, if I've called x plus 8 the length and x plus 10 the width, and I'm told that x is 15, I actually have to find it. So the length is going to be 15 plus 8. And the width is going to be 15 plus 10. Do I have units here? Yeah, centimeters. 23 centimeters and 25 centimeters.
35.
Let's try 35. Dr. Team on mental math. So could look like this. 35 by 23. Or if you did it the other way around, it could look like that. But these are the same rectangles. So there's actually two possible answers for this. Okay? Any questions? Yeah. Well, because we're told that the width is going to be x plus 10. We're told in the question that x is 50. Jeez.
Do you see that? It is 25.
Yeah. Oops, it's right. Both of us. Remember what I said last year? Don't believe everything I say. Don't trust me. Good, thank you. Okay.